Imagine standing at the top of the Burj Khalifa, 828 meters above the ground, and feeling the building sway. Yes, you heard it right. The top of the Burj Khalifa does indeed move. But why? What causes this iconic skyscraper to swing, and how did engineers ensure it stands strong and safe? Let's delve into the science and engineering behind this phenomenon. Hey everyone, welcome back to the Zane Facts channel. Stick around to uncover the engineering secrets behind the world's tallest building. Don't forget to like, subscribe, and hit the bell icon for more exciting content. Firstly, it's essential to understand that all tall buildings sway to some degree. This is primarily due to wind forces. The taller the building, the more it is exposed to high-altitude winds, which can cause noticeable movement. The Burj Khalifa is no exception. Did you know that the Burj Khalifa can sway up to 1.5 meters, about 4.9 feet at its very top? This movement is a natural response to wind and thermal expansion. The Burj Khalifa's unique shape, inspired by the Hymenocalypus flower, isn't just for aesthetic appeal. This design significantly reduces the wind forces acting on the structure by causing the wind to flow smoothly around the building. Wind forces exert pressure on the surface of the building, and this pressure increases with the height of the building. The wind creates vortices, which can cause the building to sway. Engineers use aerodynamic design principles to mitigate these effects, shaping the building in a way that allows wind to pass by with minimal resistance. The engineering team behind the Burj Khalifa, led by the firms Skidmore, Owings, and Merrill, employed several innovative techniques to manage the building's sway. The key component is the Butress Core structural system. This consists of a central core with 3 wings, each providing support and stability. The Butress Core design was crucial in enabling the Burj Khalifa to reach its unprecedented height. This system allows the building to resist wind forces more effectively than a traditional rectangular skyscraper. Over 330,000 cubic meters of concrete and 39,000 metric tons of steel were used in the construction of the Burj Khalifa. The massive foundation alone required over 45,000 cubic meters of concrete, ensuring a stable base. The Butress Core is essentially a tripod-like structure that gives the building immense stability. Each wing buttresses the other through a hexagonal central core, allowing the building to stand firm against high winds and seismic forces. This innovative design distributes the wind load evenly across the structure, preventing any single point from bearing too much pressure. To further control the sway, the Burj Khalifa is equipped with advanced dampening systems. These systems are designed to absorb and counteract the building's movements, ensuring the comfort and safety of its occupants. The Burj Khalifa employs a system known as tuned mass dampers, which are essentially large weights that move in opposition to the building's sway, reducing the amplitude of motion. These dampers are fine-tuned to respond to the specific frequencies of the building's sway, effectively neutralizing the forces that cause movement. Tuned mass dampers are a marvel of engineering. They consist of huge concrete or steel blocks that are suspended in the upper parts of the building. When the building sways, the dampers swing in the opposite direction, counteracting the motion. This system not only reduces the sway but also minimizes the stress on the building's structure, enhancing its longevity. Segment 4. Wind tunnel testing. Before construction began, extensive wind tunnel testing was conducted to understand how the Burj Khalifa would behave under various wind conditions. These tests informed the design modifications necessary to minimize sway and ensure stability. Interesting fact: 7 engineers conducted over 40 wind tunnel tests, including those for the effects of wind on surrounding buildings and the ground-level pedestrian environment. Interesting fact 8. The Burj Khalifa's tapering shape and the setbacks at various heights also play a critical role in disrupting wind flow, reducing the impact of wind forces on the building. Wind tunnel testing involves creating scale models of the building and subjecting them to simulated wind conditions. This allows engineers to observe how the building will react to different wind speeds and directions. The tests revealed that a tapering shape with setbacks would best mitigate wind forces, leading to the final design of the Burj Khalifa. Segment 5. Real-life experiences. Residents and visitors at the top of the Burj Khalifa occasionally feel the building's gentle sway, especially during high winds. However, this movement is well within safe limits and is a testament to the marvels of modern engineering. Interesting fact 9. The observatory deck on the 148th floor provides a unique experience where visitors can subtly feel the building's sway, offering a tangible sense of the structure's dynamic nature. Interesting fact 10. Despite its height and the forces acting upon it, the Burj Khalifa remains one of the safest and most stable skyscrapers in the world, thanks to its innovative design and engineering. To ensure the comfort of those inside, the building's sway is carefully monitored and controlled. The combination of aerodynamic design, structural engineering, and advanced dampening systems makes the sway barely noticeable under normal conditions. This delicate balance between movement and stability is what makes the Burj Khalifa a true engineering masterpiece. Segment 6. Comparing with other skyscrapers. It's interesting to compare the Burj Khalifa with other skyscrapers around the world. For example, the Taipei 101 in Taiwan and the Willis Tower in Chicago also employ advanced techniques to manage sway. Interesting fact 11. The Taipei 100 and 101 uses a massive 728-ton tuned mass damper suspended between the 87th and 91st floors. This damper is visible to the public, showcasing the engineering marvels within the building. Interesting fact 12. The Willis Tower, formerly known as the Sears Tower, uses a bundled tube structure. This design involves 9 interconnected tubes of varying heights, which provides great structural stability against wind forces. These buildings, like the Burj Khalifa, are designed with unique features to combat the challenges posed by their immense heights. While each structure has its own engineering solutions, the principles of aerodynamic shaping, dampening systems, and innovative structural designs are common threads that tie these marvels together. Segment 7. The future of skyscraper engineering. The lessons learned from the Burj Khalifa are paving the way for the next generation of skyscrapers. Engineers are continually pushing the boundaries of what is possible, using cutting-edge technology and materials to create even taller and more resilient structures. Interesting fact 13. The Jeddah Tower in Saudi Arabia, which is under construction, aims to surpass the Burj Khalifa in height. It will employ similar advanced engineering techniques, including a sleek aerodynamic design and state-of-the-art dampening systems. Interesting fact 14. Advances in materials science, such as the development of ultra-high-performance concrete and carbon fiber composites, are enabling the construction of lighter, stronger, and more flexible buildings. As we look to the future, the integration of sustainable technologies is also becoming increasingly important. Future skyscrapers will not only be taller and more resilient, but also more environmentally friendly, harnessing renewable energy sources and incorporating green building practices. Segment 8. Lessons from nature. Interestingly, many modern engineering techniques take inspiration from nature. The Burj Khalifa's design is no exception. By studying how plants and animals withstand environmental forces, engineers can develop innovative solutions for buildings. Interesting fact 15. The concept of the Burj Khalifa's tapering design can be compared to the shape of tall trees, which taper to reduce wind resistance and distribute stress evenly. Interesting fact 16. Biomimicry, the design and production of materials modeled on biological entities, is increasingly influencing skyscraper engineering. For example, the Gherkin in London uses a ventilation system inspired by sea sponges and anemones. By learning from the natural world, engineers can create buildings that are not only resilient and functional, but also harmonious with their environment. This approach helps in creating structures that can withstand natural forces while minimizing their ecological footprint. So, there you have it, the secrets behind the Burj Khalifa's incredible sway and the engineering marvels that keep it standing tall. If you found this video fascinating, make sure to give it a thumbs up, share it with your friends, and subscribe to the Zane Facts channel for more intriguing insights into the world's wonders. Hit the bell icon to stay updated with our latest videos. Until next time, keep exploring and stay curious.